So today we are starting with autonomous differential equation. In the last exams from this topic questions are asked like in February 2022 and in some previous exams also. So firstly, autonomous differential equation. An autonomous differential equation is an equation of the form dy upon dx equal to function of y. Means I will have an differential equation on which right side terms will be a function of y. For example, dy by dx is equal to y, dy by dx equal to y 1 minus y, or dy by dx equal to y, y minus 1, y minus 3. Now, some constant solutions of the autonomous equation can be found by locating the roots of fy equal to 0. For example, in this first example, dy upon dx is equal to y. Here, fy is y. Now, if I put fy equal to 0, I will get y equal to 0, which clearly satisfies this differential equation. So, y equal to 0 is a constant solution of this autonomous equation. Second example, dy by dx equal to y 1 minus y. Here this is fy. So here what will be the constant solutions? Please tell.
1 and 0.
Yes, y equal to 0 and y equal to 1. And in the third one also, dy by dx equal to y, y minus 1, y minus 3. Y is equals to
1, 0 and 3.
yes 0, 1 and 3.
1, 0 and 3.
Yes, correct.
3.
Now such constant solutions are called equilibrium solutions. And the roots of fy, which I am finding, are called critical points of the differential equation. Let us consider some more examples. Dy by dx equal to y square. What will be the equilibrium solutions? Put fy, which is y square, equal to 0. So equilibrium solutions will be y equal to 0 and 0.
0.
I can also call these roots of fy equal to 0 as critical points also. Okay. Second example, dy upon dx equal to sin y. What will be the critical points of this differential equation? Please tell.
It is y equal to n pi.
Yes, correct. dy upon dx equal to log y. Put fy equal to 0. This implies log y equal to 0.
Y equal to 1.
Yes, correct.
Yes. So y is 1.
Yes. Fourth one, dy upon dx equal to tan y. What will be y?
Is 0. Y equal to n pi again.
Yes, correct. Fifth one, dy upon dx
And
equal to y square minus 1. What will be the equilibrium solutions? Y equal to?
it's plus minus 1. Plus minus 1 0.
Yes, correct. Now I am discussing one interesting example. Question number 1. Given differential equation is dy by dx equal to y 1 minus y0 is equals to 1 by 2. Now which of the following are correct? Option A, yx is bounded. Option B, limit x tends to infinity, yx is equals to 1. Option C, limit x tends to infinity, yx equal to 0, yx is increasing. Option D, yx belongs to 0 comma infinity. Option E, sorry, this is option F, this is option E. Yx belongs to 0 comma 1. Firstly, try it yourself. After that, I will discuss the solution.
C option is y extend to minus infinity or infinity.
X tends to infinity.
Infinity. So option A bounded to है 0 and 1 है और option B supremum 1 है I'm guessing and option D increasing and बस A B D.
And what about F? F will also be correct.
But 1 is not including here actually and here is the solution 1.
Okay, I am discussing the solution. Firstly, you will see here Fy is equals to y 1 minus y. Now to find the equilibrium solutions, I will put Fy equal to 0. This implies y 1 minus y is equals to 0. This implies y is equals to 0 and y is equals to 1. Now, I can't say from seeing these equilibrium solutions that option B or C are correct, because till now I have not told you what is directional field. So I will go with the methods which I have taught in the previous classes. Dy by dx is equals to y 1 minus y. I will find its solution first, separating the variables. So on separating the variables, I will get dy upon y 1 minus y equal to dx. Integrating on both the sides. And you remember the trick of partial fraction?
Yes, ma'am.
So from here, what I will get, please tell.
It is a upon 1 minus y plus b upon y, or log of 1 minus y plus log of y equal to x plus c.
Yes, correct.
And it is log of y into 1 minus y equal to x plus c.
I can here also take log c. So
Yeah.
from here, it would be better
Yes,
now
we
if
can
I take
multiply.
minus common.
Multiply
If I take
1.
minus common from this term, then I can write it as minus log y minus 1. It will be simple.
Okay.
Just a second.
So that will come in the denominator and
It will be log y minus 1. So from here, log a minus log b. Log a by b. Log y
yes.
upon y minus 1
Hmm.
is equals to x plus log c. Now on simplifying, I will get y upon y minus 1 is equals to c e to the power x. Now in the question, I am given this condition y0 equal to 1 by 2. Let us
Hmm.
put this condition also. This implies 1 by 2
Zero
upon 1 by 2 minus 1 is equals to c.
minus 1.
Yes, correct. C is minus 1. Therefore, y upon y minus 1 is equals to minus e to the power x. Now, I can simplify it further. Y equal to minus y e to the power x plus e to the power x. I can take this term on the left side and I can take y common.
Yes.
This implies y is equals to e to the power x upon 1 plus e to the power x. I can further simplify this as I can divide numerator and denominator by e to the power x. 1 upon e to the power minus x plus 1. Now I can
Yes.
easily find the limit x tends to infinity. It will be,
1.
yes, correct. So from this, option B is correct, option C is wrong. Next, I need to check is yx is increasing. Now,
Hmm.
firstly, e to the power x is greater than 0. This implies 1 plus e to the power x is also greater than 0.
Yes.
Also, e to the power x upon 1 plus e to the power x. This will also be greater than 0.
Yes, ma'am.
Yes. So from here, yx is greater than 0.
Yes.
And
So it's
also,
increasing.
it will be less than 1. Na? This quantity will be less than 1.
Yes. E to power x upon 1 plus e to power x is less than 1.
Less than 1 also means yx belongs to open 0 comma 1. Clear till here?
Yes, ma'am.
So from here, option E is wrong and option F is correct.
Correct? Hmm.
Also, I can find y dash x. Y dash x
Yes.
can be simply found. So it will be e to the power minus x plus 1 into 0 minus 1 minus e to the power minus x upon e to the power minus x plus 1 square.
Hmm.
So this is e to the power minus x upon e to the power minus x plus 1 square. It will be greater than 0. So from here,
Yes.
yx is increasing also.
Yes, ma'am.
Also yx is bounded also, because yx belongs to open 0 comma 1. So yx is bounded also. So here answers are option A, B, D, F.
Yes, ma'am.
Let us discuss next question. Question number 2. Here I have given dy upon dx is equals to y 1 minus y equal to 0. Now firstly, what will be the equilibrium solutions?
1 and 0.
Yes, yx is equal to 0 comma 1 are our equilibrium solutions. And I need to find limit x tends to infinity yx. Now without applying the methods which I told you in the previous classes, I want to find this with the help of directional field. Now what is directional field? And one more condition was given, y0 is equal to 1 by 2. Firstly, I have found two equilibrium solutions, yx equal to 0
Hmm.
and yx equal to 1. And condition is given as,
Y0 equal to 1 by 2.
or I can also say this as 0 comma 1 by 2. I can say na x
Yes,
comma y.
yes, yes. Less it. Order point. Yes.
Yes. So it will lie here 0 comma 1 by 2.
Hmm.
So my next target will be to decide whether this directional field is going in the increasing side or on the decreasing side. So to check this, I will use the given condition. I will put y dash equal to, instead of y, I will put this 1 by 2, 1 minus 1 by 2, which is clearly greater than 0,
Yes.
means it is increasing. It is
Okay.
increasing and it approaches to 1. So limit x tends to infinity, yx is equals to 1. If y dash is less than 0, then this directional field will be in the decreasing side. Clear till here?
If y dash is less than 0. Right, ma'am.
Yes.
Okay.
Okay. So, or you can also see that solution is bounded also. Solution is lying in this 0 comma 1
Yes.
interval only. So solution is bounded also. Now I am giving you one question to try. Please try. Dy upon dx is equals to y, y minus 1, y minus 2, y0 equal to 3 upon 2, and limit x tends to infinity yx. This I need to find.
It is 0 because it is decreasing.
Are you sure?
See, if I put 3 by 2 in the y dash, it becomes less than 0,
Yes.
negative. So if it is y dash is negative, means it is decreasing.
Decreasing
So
is
when it
correct,
is,
but have you plot all the equilibrium solutions on the graph? As here it
yes, ma'am.
was only two equilibrium solutions. So I have plot yx equal to 0 and yx equal to 1.
Here
Here,
is 3, no? Y is 0, 1 and 2.
yes. 0, 1
So
and 2.
that's okay. If I take between 0 and 1,
3 by 2 lies in 1 and 2, na?
yes, 3 by 2 lies in 1 and 2, right?
0, 1 and 2.
Yes, ma'am.
So I will put 0 comma 3 by 2. It will lie in 1 comma 2 interval. Now I will check y dash at 3 by 2. It will be 3 by 2. 3 by 2 minus 1. 3 by 2 minus 2. It is clearly less than 0. So
Yes,
my directional field will be like this, decreasing.
yes,
So it is approaching yx equal to 1, na?
yes, ma'am. Yes, right.
So that's why limit x tends to infinity, yx is equals to 1.
1.
Now let us discuss some previous year questions, because from this topic we can expect that question can be asked. It is from June 2018. Question was from part B, means one option will be correct. Consider
Hmm.
the differential equation y dash equal to y minus 1, y minus 2. Which of the following statements is true? Option A, if y0 is equals to zero point 0.5, then y is decreasing. Option B, if y0 is equals to 1.2, then y is increasing. Option C, if y0 is equals to 2.5, then y is unbounded. Option D, if y0 is less than 0, then y is bounded below. Try this question. After that, I will discuss the solution.
It is C.
Yes, correct. Y minus 1, y minus 2. Now put fy equal to 0, and equilibrium solutions will be,
0, 1, 2.
yes, correct. Now I will plot the graph. I have y equal to 0, y equal to 1, y equal to 2. And first option is y0 equal to zero point 0.5, or I can say y0 equal to 1 by 2. Now it will lie in the interval 0 comma 1. So
Yes.
0 comma 1 by 2, and y dash is this term. So y dash at 1 by 2, it will be less than 0 or greater than 0?
Greater than 0.
Yes, greater than 0. So as it is greater than 0, so directional field will be increasing.
Increasing, but it is saying decreasing.
Yes, that's why option A is wrong. Option B, y0 equal to 1.2. It will lie somewhat here, 0 comma
One.
1.2.
Yes,
Now y dash will be greater than 0 or less than 0?
less than 0.
Yes. So directional field
Decreasing,
will,
but it is saying increasing. Yes.
yes. That's why option B is also wrong. Option
Hmm.
C is saying y0 equal to 2.5.
So it is like
So here, option C, y dash is greater than 0 or less than 0?
greater than 0.
Yes. So it is clearly unbounded.
Yes, ma'am.
So option C is correct. And in option D, it is saying y0 is less than 0. I can take any value. I can take y0 equal to minus 1, 0 comma minus 1. So y
Hmm.
dash will be greater than 0 or less than 0?
It is greater than 0. I mean, less than 0, sorry.
Less than 0. Means it will
Mhm.
come like this. And it is saying y is
Bounded with.
bounded below. But here y is unbounded below.
Yes.
So that's why option D is also wrong. And answer is option C. Next question. Consider the solution of the ordinary differential equation y dash t equal to minus y cube plus y square plus 2y subject to y0 equal to y naught, which belongs to 0 comma 2. Then limit t tends to infinity, yt belongs to option A minus 1 comma 0, option B minus 1 comma 2, option C 0 comma 2, option D 0 comma positive infinity. Try this question. This was from June 2017 exam, part C, MSQ. More than one option can be correct.
Is it minus y cube plus y square plus 2y?
Yes, minus y cube plus y square plus 2y.
Okay, ma'am. It's actually coming to be 2, so it can be in option C.
Why
C
not?
option
Why not option B also?
0, because the thing is, why not belong to 0, 2? See, we have the critical values as -1,
Minus 1,
y
0,
equal
and
to
2.
0. Sorry, acha, I have done some mistake. I think y equal to -1, I'm getting y equal to 2 and y equal to 0. ठीक है, critical values ठीक है. Hmm. It is y square minus y minus 2. Right? So it is y minus 2, y plus 1.
Yes. So put Fy equal to 0. This was Fy. So
Yes.
equilibrium solutions are y equal to
0,
0, minus 1, and 2.
1 and 2. Yes.
Now I can plot this.
Mhm.
Y equal to 0, y equal to minus 1,
2.
y equal to 2. Now it
Mm.
was given that y0 is equals to
Belong to
y0,
0.
which belongs to 0 comma 2. I can take y0 as 1.
Yes.
This. Now y dash is greater than 0.
Yes, ma'am.
So limit x tends to infinity, yx is equals to 2.
2.
Now my equilibrium solutions are 0 comma minus 1 na?
Yes.
So I will mark the options which have 2. Option B and C both have as a equilibrium solution, sorry, both have 2, and also
Yes.
equilibrium solutions are 0 and minus 1. That's why option B and C will be correct. These equilibrium solutions, you cannot say that it belongs to 0 comma 2. This was just a condition. I am finding na equilibrium solutions as it is
Yes,
a
ma'am.
solution of a autonomous equation, so it can come in this 0 and minus 1. That's why option B and C are correct. Now let us discuss next question. It was from December 2011. Part B question. Consider the equation dy upon dt equal to 1 plus f square t yt y0 equal to 1 comma t greater than equal to 0, where f is a bounded continuous function on 0 comma infinity. Then a part, this equation admits a unique solution yt, and further limit t tends to infinity exists and is finite. Option B, this equation admits two linearly independent solutions. Option C, last option is this equation admits a unique solution. and further limit t tends to infinity, yt is equals to infinity. Try this question.
इसमें एफ टी कुछ एज्यूम करना पड़ेगा।
Yes,
तो कोई भी बाउंडेड फंक्शन 0 to infinity में लाइक t into 1 minus t ले सकते हैं हम लोग।
but you can take simply ft as 0 or 1. Why to take a complicated example? I'm discussing the
Okay.
solution.
So if I got it. Okay. If I take ft as 1, 0,
ft 0 is more simple.
then it will become only one constant.
Yes, it will be y. Now,
It will be y equal to x plus c. So अगर x0 then y1, तो c is 1. So this will be y equal to x plus 1.
y equal to x plus 1. How come?
If I take ft as 0, then dy by dx equal to 1. It is 1 plus x square t
It is
by2.
yt also, na here?
Achha, it's a bracket.
Yes,
It's a
yes,
bracket. Okay,
yes,
sorry.
yes.
It's a bracket. Got it. So it will be yt. So
So I
y
can
is now
separate the
0. Yes,
dy.
critical point. Or I can do is log y equal to x plus log c.
Yes, correct.
So y upon c equal to x, so y equal to cx.
Yes.
So it becomes
Condition
no,
is y
it
0
is y
equal to
equal
1.
to c e power x, e to power x. Y equal to c e to power x.
Yes.
So if x is 0, then y is 1. Then c is 1 again. So that becomes y equal to e to power x.
Yes.
Okay. So equation admits a unique solution y.
And also, if I
Um,
find limit t tends to infinity, it will be infinity.
infinity, yes.
So our option will be D part. D part will be correct.
this equation is in further.
Because option A was saying that the solution is unique, but limit t tends to infinity is finite. But I am getting
And it is
infinite.
finite,
Yes.
infinite.
And I am not getting two Li solutions.
Yes.
So our answer is option
Yeah.
D.
So it is a unique solution. Hmm. Option D
And
is correct.
one more thing I want to know, why I'm not able to use
Mhm.
directional field here.
Uh, Here, if I put, see, condition is not given. See, if I put y is 0,
Condition
only
is,
one point is there, no? Y equal to 0.
yes, condition is given, but
Y is 0, so we don't have some
only one
hmm,
equilibrium solution was given.
bounding. Yes.
To find a directional field, I need at least two equilibrium solutions.
Hmm.
Okay.
Hmm.
So next question.
तो इसमें कुछ काउंटर एग्जांपल भी सोच सकते हैं मान लो जैसे हमने 0 लिया अगर हम 1 लेते हैं तो क्या होता ऐसा कुछ
एफ टी
तो वो
इक्वल टू
2y
वन,
हो जाता फिर
वो टू वाई हो जाता. यस, टू वाई हो जाता तो
देन अगेन सेम
यहाँ
इज
पे टू टी हो जाता, तो सी ई टू द पावर टू टी हो जाता. तो
हाँ
सोल्यूशन y
सेम
इक्वल टू
कंडीशन
e to the power 2t. Same, yes. Okay, let us
ठीक
consider one more.
हम्म,
It was from June 2012. Again, part B question. Consider the initial value problem. Y dash t equal to ft yt. This question is similar as previous question, y0 equal to 1, where f is a mapping from R to R. This is continuous. Then this initial value problem has option A, infinitely many solutions. For some f. Option B, a unique solution in R. Option C, no solution in R. For some f. Option D, a solution in an interval containing 0 but not on R for some f. So firstly tell me that here I can take any example of f or not.
we have to take some continuous function
Uh,
for f but the constant function is also continuous so we can take ft as some constant c
but I cannot take this. Yes, I can take. Yes, yes, I can take any constant function. I can take ft as 1 or anything.
yes
Ft equal to 1 will be easy. Try this and tell me the answer. After that I will discuss. Solution will be same as the previous one. Solution will be y equal to c e to the power t only, because if I take ft as 1,
Yes, ma'am.
I take
Mm-hmm.
ft as
Right.
1, solution will be y equal to c e to the power t. Condition is also same. This implies c is
Mhm.
1. Therefore, solution is y.
The B is the answer.
Yes.
Uh, a B is answer a unique solution in R.
Yes, correct.
Y equal to e to power 6.
Yes. Because y equal to e to the power t, I am getting an unique solution. So option A will be discarded. Option C is also discarded.
It's okay.
So directly I can say, and this y equal to t solution is unique also, and it exists
Mm.
for all t belongs to real numbers, na? So
Yes,
option
ma'am.
D is also wrong. So correct answer is option B. Answer is option B. Now I am discussing last question from this topic, and also I will give assignment for this topic. Question number, whichever it was. Now this question is from February 2022 exam. Again, part B question. This is an interesting question. Consider the following two initial value ordinary differential equations. Part A, dx upon dt is equals to x cube, x0 is equals to 1. Please mute yourself. Option B, dx upon dt is equals to x sine x square, x0 equal to 2. Now, related to these ODs, we make the following assertions. First one, the solution to A blows up in finite time. Option 2, the solution to B blows up in finite time. Which of the following statements is true? Option A, both first and second are true. Option B, first is true, but second is false. Option C, both first and second are false. Option D, first is false, but second is true. Try this question. Got any solution or should I solve?
Just a minute, ma'am.
Okay.
Ma'am, please you solve because she blows up का meaning clear नहीं है मुझे.
Okay, I'm discussing. So, solution.
आपको in finite time.
Yes, I'm discussing. Option A is dx bound dt is equals to x cube. Now here equilibrium solutions will be x cube equal to 0. X equal to 0 is an equilibrium solution.
0.
Yes. Again, here only one equilibrium solution is there, so I cannot plot a directional field. So I need to solve this differential equation by the methods which I have taught you earlier. So I can separate the variables x to the power minus 3 dx equal to dt. Integrating on both the sides, it will be minus 1 upon 2x square equal to t plus c. Now a condition was given x0 equal to 1. By using this condition, I can find the value of the constant c. This will be minus 1 by 2 c. C is minus 1 by 2. Therefore, minus 1 upon 2x square is equals to t minus 1 upon 2. I can simplify it further. It can become 1 minus 1 upon 2x square equal to 2t minus 1 by 2. 2 will get cancelled out in this and it will become x square equal to 1 upon 1 minus 2t. So this is x equal to plus minus under root 1 upon 1 minus 2t. Now it is saying the solution to A blows up in finite time. Means in a finite time is the solution which I have found for option A blows up. Blows up means it goes to infinity. Simple meaning. Blows up means it goes to infinity. So I can clearly see that our solution goes to infinity if t tends to 1 by 2.
T tends to infinity, then it goes to 0.
Yes.
So if t tends to infinity, then it goes to 0. If t tends to infinity. Achha, it goes to infinity if, yes, t tends to 1 by 2, right?
Yes, I want to find a
Yes, ma'am.
finite time so that it blows up, means goes to infinity. So clearly it blows up in a finite time. So option A means option statement first is correct. As statement first is correct, so option C and D are discarded. Next, I want to check dx upon dt. Dx upon dt is equals to x sine x square. Firstly, tell me what will be the equilibrium solutions.
It is 0 and plus minus root and pi.
Yes, correct. and condition was given as x0 equal to 2. So I can find this solution by plotting directional field. Equilibrium solutions are x equal to 0 and x equal to plus minus under root n pi.
root n pi.
Now I need to n can be a natural number. So I
Yes.
need to take a value of n so that this condition will lie in that particular interval. So if I take n as 2, it will become
Mm,
root 2 pi and minus root 2 pi, and my
yes.
solution will lie somewhat like here. It is 0 comma 2. Okay, so
Yes.
here x dash t is greater than 0 if I put x as
Mm,
2.
yes.
So it is approaching to this root 2 pi.
Root
So
2 pi.
limit t tends to infinity, xt is equals to root 2 pi.
Root 2 pi. Yeah.
And
Yes.
it was saying that the solution blows up, means it goes to infinity. But clearly I am getting a solution, a finite solution, na? So
Yes,
that's
ma'am.
why statement second is false. Statement first was true, statement second is false. So our option B is correct. So answer for this question is option B. So autonomous equation topic is completed till here. Any doubt?
No, ma'am.
Okay.